Foundation lecture number 3, Deep Foundations. When the top soil layer doesn't have the required engineering properties, it's mainly weak material and it cannot carry the structure's load, we need to use deep foundations to transfer the load from the top layer to lower layers where it has the required engineering properties. We have different types of deep foundation or piles, and we're gonna look at different types of materials for pile construction. One of the most common type of materials used in pile construction is steel. So we have steel piles. It can be a pipe pile, which can be driven into the ground. It can have an open end or a closed end. And then in some cases, we can even fill the pipe pile with concrete to increase the strength of pile. Another type of steel pile is the use of H sections for pile construction, and again this will be a driven pile. The construction method will be driven piles. Rolled sections, fabricated shapes, and sheet piles are other examples of using steel for pile construction. So these are examples of pipe pile with closed end or open end, and these are examples of sheet pile. Again, the construction method for all of these is driven piles. This video is an example of using helical pile and to transfer the superstructure's load to lower layer where we have again the required properties. This simple technique can be used to repair damage in a foundation of a structure. As you can see here, the foundation is cracked. Using helical piles, load is transferred to lower layer where soil has the required properties, and this way the issue with the foundation can be addressed. So as I mentioned earlier, two main types of steel piles are H piles and also pipe piles. So this table here provides the common H pile sections used in the United States. You can see that we have HP sections, 8 inches up to 10, 12, 13, and 14 inches. Also, you can see the weight in pound per feet. The table also provides information on depth and width of flange, also thickness of web and flange. So, this table is just to give you an idea what are the common H pile sections used in pile construction. And then we have this table which provides information on selected pipe pile sections used in pile construction in the United States. We have the outside diameter, the range, and also the wall thickness. Next, we have concrete as a material used in the construction of piles. When talking about concrete, then we have two types of products. It can be a precast pile or cast in place piles. Precast piles, the construction method is pile driving. It can be prepared using ordinary reinforcement, and the two common cross sections are square and octagonal cross sections. So this is driven piles, and then we have the second construction method where we basically make a hole in the ground, place the rebar, and pour concrete. So that's going to be cast in situ or cast in place piles. Next material is wood or timber piles, and when needed, we can also use the combination of two or more materials together, which we refer to that as composite piles. So basically in composite piles, the upper and lower portions are made of different materials. So this is an example of a composite pile where the upper section is concrete and the lower section is edge section. We have a steel, precast concrete, cast in place concrete, and timber as other materials used for the construction of piles. So these are different pile types based on construction material.
Pre-stressed, precast concrete piles are among the first pile systems to be used after wooden piles. They are displacement piles and are pile-driven. They are suitable for almost any soil condition. Vroom van Dieringstechnieken uses rigs with continuously variable hydraulic drop handles. Concrete piles are available in a large number of standard lengths and square sizes. They are used for residential, utility, and infrastructure projects, but also in projects where high stress demands are placed on the piles, for example, in civil engineering, or for small projects requiring rapid, flexible realization. It involves a controlled driving process where Vroom has years of experience. The correct position of the pile is prepared based on the spire. When the pile is located under the ram, it's driven in a vertical or braced position. When pile driving, calendering is used to determine the soil condition. During underground construction, such as cellars and tunnels, the piles can be driven from the existing ground level and then further driven in.
So precast, pre-stressed concrete piles, two different type of equipment can be used for driving piles into the soil, which includes impact hammers or vibratory hammers. This slide provides typical pre-stressed concrete pile used in the United States. As I mentioned earlier, we have two main types of cross sections. You can also see that the diameter changes from 10 inches to 24 inches. This table provides more information, but again, the purpose of this table is for you to have ideas, get some idea on what are the typical sizes for precast concrete piles used in construction. You can also see what is the design bearing capacity in kips or strength of concrete in PSI. And then we have the second type of pile construction, which is cast in place.
Type HBF vibra piles are cast in situ driven displacement piles. Vroom van Dieringstechnieken has various types of hydraulically driven piling rigs for pile driving the casing in which the concrete pile is produced. The advantages of vibra piles comes to the fore during changing soil conditions, longer piles, or when using piles which are subjected to greater loads. The shape of the vibra pile is based on the bearing capacity needed and soil condition. The depth of the casing to be pile driven is determined by the soil structure. Producing vibra piles takes noise reduction into account by placing a noise-reducing sound jacket around the casing. Pre-drilling is a possible option to reduce vibration during the pile driving process. Pre-pile driving also occurs, especially at locations where there could be unexpected or large obstacles in the soil. Type HPF vibra piles are suitable for residential projects, buildings, sewage purification plants, and infrastructure and energy sector projects. The piles can be produced relatively quickly. They are displacement piles with no outcoming associated soil. A centering jig keeps the shoe in place. The detachable base cover can be fitted with sealing tape to close the casing during pile driving. The casing is brought into the correct position above the detachable base cover and will then be pile driven. When the correct depth has been reached, the hammer is disconnected and checked whether the inside of the temporary casing is clean and dry. Then, reinforcement with spacer sleeves is fitted at the right height. With an anchor pile, reinforcement is fitted over its entire length. A concrete pouring silo is used to fill up the concrete into the casing, after which the driving hammer is again connected to the casing. When the piling rig withdraws the casing, the detachable base cover remains behind and shapes the vibra pile in the soil. Vibra piles can always be made to the right depth. If required, a pile can be finished directly at working length. For each subsequent pile, the same casing is positioned over a new shoe and pile driven into the soil. All the Type HPF vibra piles produced by Firmenverdelingstechnieken have been subjected to sonic integrity testing by an independent consultant. Firmenverdelingstechnieken is ready to support you with advice.
And then another video which goes over
Harbor Freight for affordability, but durability
timber
goes right
as a
along with it.
construction
You see, we
material.
have- and then
Have you ever wondered what happens on site when the soil that you're building on is too soft? Well, one of the options is you drive piles. So we smash the piles down until we hit good ground. We started off by driving a pile in each corner of the section. You want to be making sure your piles are long enough. Timber piles, there's going to be 72 under this slab here on the townhouse job. Building 2 townhouses here side by side with a firewall in the middle. When I first started my apprenticeship and we were digging for
Okay. One other thing that we need to consider when trying to select the best option for our project is the environmental exposure. What you see here is corrosion of a steel. We have degradation of concrete pile, and you can even see rebars in this corrosion of rebars in this picture, and also deterioration of timber piles. So this is an example of a composite material. This is composite jacketed wood pilings, which were used at the waterfront installation. So again, we need to make the best decision based on different parameters, including environmental exposures. So now let's look at pros and cons of each of these materials. for pile construction. First, we look at a steel. The usual length is between 50 feet to 200 feet, but the maximum length is practically unlimited. It's easy to handle. It's a strong material. It can stand high driving stresses and it can penetrate into hard layers. And again, a strong material provides high load carrying capacity. Compared to some other options, it can be more expensive, especially using impact hammer. It can produce a lot of noise. Still, whenever we work with a steel, we need to consider corrosion. And using H-pile, we need to pay attention that H-piles may be damaged or deflected from the vertical load during driving. Then we have precast or pre-stressed concrete. Precast, the length can go between 30 to 50 feet, and if you have pre-stressed, then it can go up to 150 feet. The maximum length is 100 and 200 for precast and pre-stressed concrete. These are strong materials. They can be subjected to hard driving. Since we have the concrete covering rebars, it's corrosion resistant, and it can be easily combined with concrete superstructure. Difficult to achieve proper cutoff, and it can also, again, this depends on the size of the precast concrete elements that we have, but it may also be difficult to transport them to the job site. Then we have cast in place, which can be cased cast in place or uncased cast in place concrete. So the usual length is between 15 to 50 feet, and then we have the maximum length. Let's look at pros and cons of cased cast in place concrete. Compared to some other options, it can be cheaper. It provides us with the opportunity to do the inspection before pouring concrete, and it's easy to extend. It's difficult to splice after hardening of concrete. Thin casings can be damaged during the driving process. Uncased, it can be cheap at the beginning and it can be finished at any elevation, but since we don't have anything around the concrete that we are pouring, it allows voids to get into the concrete and it can have a negative impact on the strength of concrete. It's difficult to splice after concreting. In soft soils, the sides of the hole may cave in and squeeze the concrete that was placed. And then finally, we have wood as a construction material for piles. The usual length is between 30 to 50 feet, and the maximum length can go to up to 100 feet. So it's cheap, it's easy to handle. If it's permanently submerged, then it's very resistant to decay, but decay above water table can be damaged when the pile is driven into the soil. Compared to a steel or concrete, it provides lower load bearing capacity and it has lower resistance to tensile load when spliced. Next, we want to look at different pile driving equipment. So as I mentioned before, there are two different approaches. One is to use an impact hammer, and the other approach is to use vibration. This is one of the simplest equipment, one of the oldest type of hammers. It's basically the weight is raised by a winch and then allowed to drop from a certain height. Very simple, very old, but it also a disadvantage of this type of hammer, which is called drop hammer, is that it has a very slow rate of hammer blows. So another type of hammer is called single acting steam hammer. In this case, and you can see the detail here, ram is raised using a steam pressure, and then it's dropped under its own weight, dropped by gravity. So this is single acting steam hammer, and then we have dual acting steam hammer. Basically, a steam is used to raise the ram and then push it downward. This increases the impact velocity of the ram, and also we have a higher rate of blows. Another equipment is diesel hammer. During the operation, the ram is first raised, fuel is injected, then ram is released. When the ram drops, it compresses the air-fuel mixture, ignites it, and this action pushes the pile downward and raises the ram. It works well under hard driving condition, not good when we have soft soil. Then we have a vibratory pile driver, so impact, vibration. In vibratory pile drivers, two counter-rotating weights are used to cause a vibration and move the particles around an empty space for the downward movement of pile. We also have hydraulic impact hammers, and another more advanced technique is water jetting, where water is used to again move the particles around, free up a space, and then downward movement of pile. In this slide, you can see examples of commercially available pile driving hammers. Maker of hammers, so you see different makers, the model number, type of hammer, if it's single acting, double acting, or if it's differential or diesel, then rated energy, number of blows per minute, and weight of ram.